All right, today we are multiplying and dividing fractions. So this is actually, I think, easier than adding or subtracting them. So our first problem, it says reduce all answers to their lowest terms. So after we have done the division, we're always going to remember to reduce. So I have 5/8 divided by 3/4. Ooh. Yep. Okay, now the way that you can remember with dividing fractions is this: copy, dot, flip. So I'm going to copy my first fraction. I'm going to put a dot to show I'm doing multiplication, one of the many symbols for multiplication. I'm going to flip the second fraction so that I have its inverse or reciprocal. Okay. So after I have turned my division into a multiplication problem, I solve this like I would a multiplication problem with fractions, which means I multiply straight across. I multiply the numerators. 5 times 4 is 20. And then I multiply the denominators, the bottom part. 8 times 3 is 24. Then I reduce. Both of these numbers, 20 and 24, are even. So I can divide them both by 2 to start off. Okay, 20 divided by 2 gives me 10. 24 divided by 2 gives me 12. Again, I still have two even numbers, so I'm going to divide by 2 again. When I divide 10 by 2, 10 divided by 2 gives me 5. 12 divided by 2 gives me 6. So that is reduced. They're not both even. They don't have any more common factors that we can divide them by. So my answer is 5/6, or 5/6. Okay, now we have a multiplication problem. And we can show multiplication with the times like this, or with the dot. I'll write it with the dot. No. 11/13 times 3/22, or 11 over 13 times 3 over 22. Okay, we're multiplying them. We multiply straight across. 11 times 3 is 33. 13 times 22. Let's see. 22 times 10 would be 220. Plus 22 times 3 would be 66. So 286. I'll double check. 13 times 22 equals 286. Okay, now I have to see if I can reduce these. They are not both even, so they're not both divisible by 2. They don't end in 5 or 0. I can't divide them both by 5 or 10. Maybe 3. So I know 3 times 11 is 33. So I could do 33 divided by 3 and get my whole number, 11. Let's see if I can do 286 divided by 3. I'll check it in my calculator. I get 95.33333. So it's not divisible by 3. I'm going to try this. I'm going to try to do 286 divided by 33. Nope, I get a decimal again. So if I want to, I'm just going to double check this whole problem. I can make factor trees. We did this in another one, but factor them to their primes. 3 and 11. 3 times 11 is 33. 3 and 11 are primes, so I will circle them. 286 is even, so I'll divide by 2. I get 143. I can't think of anything that 143 is divisible by, so I'm going to go and I'm going to cheat. I'm going to look at the fast way to just see if 143 is a prime number, because then I'll know whether I can divide it by anything or not. If it's a prime, it's only divisible by itself in 143. Prime? Question mark? Okay. I'll see, is it prime or composite? It's not a prime. What are the factors? Come on. Why does this hate me today? Okay, well, that's just not working, so. I'm stressed. Let me just close this out, I guess. Let's try again. Stress because my internet's slow. And I do not have time for it. Dear goodness. So to see what 143 is divisible by, after knowing it's not prime, I'm going to search 143 factors to see what it is divisible by. 1, 11, and 13. Okay, so let's try dividing it by 13. 100 or 11. 143 divided by 13 equals 11. 13 is a prime and 11 is a prime. So, yay. This shows we can reduce it. So here's how I'm going to write this. I have 33 over 286, but this time I'll just write it down here. I'm going to write what prime factors we have. So 33 I factored down to 3 times 11 over 286 we factored down to 2 times 13 times 11. Now, if you missed this in earlier videos, I'm just going to remind you that the way that you divide down the factor tree, you can multiply back up. So if I did 286 divided by 2 equals 143, 143 divided by 13 is 11. I could do 11 times 13 and get 143. 143 times 2 equals 286. Another thing I could do, if I put in 11 times 13 times 2 in my calculator, I would get 286. So that's why 286 equals 2 times 13 times 11, and 33 equals 3 times 11. Now, here's the trick. Here's why we did this. If we have a prime that matches on the top and bottom, we can chop it off, cross it out, and that's how we're going to reduce. Once we have no more matches to cross off, then we see what's left. So on the top, I have a 3 left. There's no more matches between the top and the bottom. On the bottom, I have 2 times 13 left. 2 times 13 would give me 26. So this reduces down to 3/26. Oh, come on. Stop, please. 3/26. Okay. Reduce all answers to their lowest terms. 4/9 divided by 6. But 6 isn't a fraction. Let's make it a fraction. 4/9 divided by 6. And what I'm going to do to make it a fraction is put a 1 underneath it, because 6 divided by 1 is 6. So they're equivalent. So I can replace that 6 with 6/1, and I can give myself a fraction in the process. Now, since we're dividing, I'm going to follow the copy dot flip thing. Copy dot flip the second one. And then now I'm multiplying. Hooray. Multiply straight across. 4 times 1 is 4. 9 times 6 is 54. These numbers are both even. I'm going to divide them by 2 to reduce, or you can do the factor tree method, but I think that will take me more time right now, so I'm going to do this. 4 divided by 2 is 2. 54 divided by 2 is 27. Okay, 2 is our smallest number. It is a prime. We cannot divide it by anything else. So is 27 divisible by 2? No. So this is reduced. You can't reduce this anymore. If the smallest number in your fraction won't fit into the other one, and you've already reduced it down to something like a prime, then you won't have to reduce anymore. Okay. 7/9 divided by 3/5. Copy dot flip. Now we're multiplying. Okay. So multiply fractions straight across. 7 times 5 is 35. 9 times 3 is 27. Okay. We have an improper fraction. That's okay. We'll reduce it first if we can. They're not both even. They're not both divisible by 5 because they don't both end in 5 or 0. I'm not sure what they might be divisible by. But they aren't prime numbers, so let's factor them. 7 times 5 is 35. 27 is divisible by 3. 3 times 9 is 27, so 27 divided by 3 is 9. 9 is divisible by 3. If you do 9 divided by 3, you get 3. Now, there's no common factors in either of the factor trees, so if I try to do my trick, write down the prime factors over the other prime factors for the denominator, there's not going to be anything to cross off, so I can't reduce this. All I can do is turn it into a mixed number, and that's what they want me to do here. So here's what I'm going to do. I've got 35 divided by 27. I can put that in a calculator. If I do that, I'll get 1 point something, 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 something. So I have one whole. What I essentially did is I just took one whole 27 out of 27 away from my numerator. My denominator, 27, stays the same. Since I took 127 away from my numerator, which was 35, I do 35 minus 27 maybe in a calculator, and I'll get 8. So my answer is 1 8/27. Okay, 20 over 27 divided by 10 over 9. I'm dividing. I don't want to divide fractions. As it showed you in the video, it just is messy. So we are going to switch to a multiplication. Copy the first fraction, dot, switch to multiplication, flip the second fraction upside down. Now I'm multiplying. Once you've rewritten a problem, you forget about this. This is the problem now. 20 times 9 is 180 over 27 times 10 is 270. Here's a cool trick. If both your numerator and denominator end in zeros, you can just cross off the zeros. That's a way of reducing it, because if numbers end in 0, they're divisible by 10. So if I wanted to not just cross them off, if I want to see the steps, I would reduce them. Think, what is something they're both divisible by? Since they both end in 0, they're both divisible by 10. If I did 180 divided by 10, I'd get 18. If I did 270 divided by 10, I'd get 27. That's why crossing off that 0 works. So now I'm working with 18 and 27. I know 18 and 27 are not both even numbers, but since I know my multiplication facts, I know they're both divisible by 3. So I'm going to do that. Just like when balancing an equation, when you say what you do to one side, you do to the other. With fractions, what you do to the top, you do to the bottom, or what you do to the bottom, you do to the top. So we're going to divide both the top and the bottom by 3. 18 divided by 3 is 6. 27 divided by 3 is 9. 6 and 9 are also both divisible by 3. I'll do that again until I cannot reduce any more, until there are no more common factors. 6 divided by 3 is 2. 9 divided by 3 is 3. So I've reduced this down to 2/3. Okay, reduce all answers. 4 times 5/7. 4 times 5/7, and I want to be looking at two fractions, so I'll just put a 1 underneath the 4, because 4 divided by 1 is still 4. Just writing it in like a fraction form. Okay, when I'm multiplying, I multiply straight across. 4 times 5 is 20. 1 times 7 is 7. Now, 7 is a prime number, so I'm going to look at 20. Is 20 divisible by 7? No, you're going to get 2 point something if you put that in a calculator. You have to get a whole number with no decimal in order for it to be divisible by something if you're doing a calculator test. So here's what I'm going to do instead. I'm going to think, how many times can I fit 7 into 20? Almost 3, but not quite, because 7 times 3 is 21. So since it's not quite 3, I can fit it in twice. The calculator way to do this is like the 20 divided by 7. You'd get 2 point da 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 da. You keep the 2. Then you write down your denominator, because your denominator doesn't change, stays the same. Now what I've done is I've taken 2/7 away from this numerator. 2/7, 7 and 7. 7 plus 7 would be 14, or 2 times 7 would be 14. So since I've taken 2/7, which is 14, away from the numerator, 20, I'm left with 6. So my answer is 2 6/7. 2/3 divided by 1/12. I don't want to divide fractions, I want to multiply them. So I'm changing my division problem to a multiplication problem. Copy, dot, flip. Okay, now this is the problem we're looking at. We've got 2/3 times 12 over 1. 2 times 12 is 24. 3 times 1 is 3. Here's what's easy about this one. If you put this in a calculator, 24 divided by 3, you're going to get 8, which is a whole number. So there's no remainder. You don't have to try and find what the other fraction is because you didn't get a decimal when you did 24 divided by 3 in your calculator. 24 divided by 3 as a reduced version is 8. Okay, on to the next lesson.